This video shows a compilation of 5 tools related to synthetic Violin log and porosity prediction. The tools are selected by pressing the appropriate radio buttons. These are Formation Density from Porosity and Matrix Mineral, Formation Density from Porosity and Grain Density, Sonic Velocity from Porosity and Matrix Mineral, Porosity from Formation Density and Matrix Mineral, and finally Porosity from Sonic Velocity and Matrix Mineral. The tools can only be carried out on multi-datasets and are therefore only available to licensed premium subscribers. Demo versions are, however, available with a standard subscription. Let's take a look at the licensed versions. We first select the tool from the radio button selector. Let us start at predicting formation density from porosity and matrix mineral. A valid licensed company name has to be entered into the text box. We then press the Go button. The Multi-Data Entry tool opens in a new tab in your web browser. The first worksheet gives some introductory instructions. The prediction tool follows in the second worksheet. Input data cells have a yellow background color, whereas the prediction data are given in cells with green background. Only yellow cells can be edited, all other cells are locked. We first enter or paste depths, porosities and matrix minerals into columns C to E. For all the tools, depths should be entered at increasing depths above or below mean sea level. Water, oil and gas densities should be entered into cells B3 to B5. And gas-oil contact and oil-water contact should be entered into cells B7 and B8. If oil and or gas is not present, then leave the associated cells empty. Default matrix densities for different minerals and lithologies are given in cells B11 to B18. But these can be altered by entering new values. A user-defined mineral or lithology and associated matrix density can be entered into cells A19 to B19. If the default values have been altered, then these can be redisplayed by ticking off cell B21. The predicted formation densities are given in column F and are displayed as a synthetic density log in the crossplot. Let us go back to CARP and select one of the other tools. This time we will predict formation density from porosity and grain density, and we select this option from the radio buttons. We enter or paste depths, porosities and grain densities into columns C to E. Water, oil and gas densities should be entered into cells B3 to B5, and gas-oil contact and oil-water contact should be entered into cells B7 and B8. As previously, if oil and or gas is not present, then we leave the associated cells empty. The predicted formation densities are given in column F and are displayed as a synthetic density log in the crossplot. We will go back to CARP and select one of the other tools. This time we will predict sonic velocity from porosity and matrix mineral, and we select this option from the radio buttons. We enter or paste depths, porosities and matrix minerals into columns C to E. Default transit times for water, oil and gas are given in cells B3 to B5. These can be changed, although the default values should be fine. Gas-oil contact and oil-water contact should be entered into cells B7 and B8. Default matrix transit times are given in cells B11 to B18. The predicted sonic velocities are given in column F and are displayed as a synthetic velocity log in the crossplot. We will go back to CARP and select one of the porosity tools. We will first predict porosity from formation density and matrix mineral. We need to enter or paste depths, formation densities and matrix minerals into columns C to E. Water, oil, gas and matrix densities should be entered into column B, or we can apply the default values. We also need to enter gas-oil contact and oil-water contact. The predicted porosities are given in column F and are plotted against the depth in this plot here. Let's go back to the radio button selectors in CARP. In the last tool, we will predict porosity from sonic velocity and matrix mineral. We need to enter or paste depths, sonic velocities and matrix minerals into columns C to E. We are already familiar with the input into column B, and we will apply the default values. The predicted porosities are given in column F and are plotted against depth in this plot.